Hello everyone and welcome to this quick overview over the second course of Data Science 101. My name is Vitalii and today I will tell you how we can make AI more accessible for everyone using decentralized data science and MLOps. So, quick overview. Firstly, I will bring you a bit of problem context, then we will have a look at motivation and main goals. We'll have a look at the related work as well, because it's pretty important to understand how those problems are solved today, and if they are solved today at all. Then we will dig in deeper into Ratio1 core concepts, how it works, how it's organized, and we'll have a look at some practical applications. So yeah, we have this great concept of ubiquitous computing, which means making computations everywhere, bringing computational capabilities into your everyday life. But right now we have a lot of computation is still sticks to some centralized entities, which bring you very high infrastructure costs. If you are a small or medium-sized company, it's very difficult to get any at a decent price, of course. You still have this centralized dependency that you depend on one entity, which is not so good. What if this entity falls down or has a fault, and then your whole system is down? It always brings some complex workflows of how your data is processed, what can you do with it, what cannot you do with it. And there's always a requirement of having specialized people who know how to work with it. You need a lot of DevOps expertise just to keep it working, to maintain it. And right now there are billions of devices which don't do anything but could contribute some computational power to a centralized network, and why not using it? So decentralization brings us some benefits, that we get computational power at reduced costs, because computational power which was idle before could be used right now by someone, and you could get paid for it, of course. We have the distributed liability. You could have your application deployed in multiple places, in multiple regions, and you get basically no downtime. If one of region fails or if there are outages. Another important thing is making deployment simplified, so anybody can deploy an application, and bringing in democratic access, so there is no censorship. Anyone can come to the network, anyone can use computational power of the network, and anyone can contribute to the network. So our main motivation and what are our research goals. The most important one is democratize AI access and data control, making AI training available from medium companies to small companies, even for individual people, for anyone. So anyone can train their own model using their data. And what is very important here is data control, because your AI, your data, so no one else can access your data. You have full ownership over your data. Another important point is having a sustainable ecosystem. So we have economically efficient AI infrastructure that anyone can use, anyone can contribute to it. Making the development and apps deployment easy is really crucial. So you don't need any specialized prior knowledge into the topic. You don't need to know DevOps, or you don't you don't even need to know AI, how AI is organized, what stays under the hood. You just have to bring well, let's give a simple example. You have to bring a bunch of photos of your cat, and afterwards it's pretty easy for you to train a model which can detect if it's your cat or not. For example, to decide if the automated system can feed your cat, or can feed the cat that came to the bowl or not. And the last one, but not least, is economic fairness, that rewards are tokenized and there's no central rent. There's no central entity which will decide if you have to pay, if you don't have to pay. You pay as much as you use, so you pay only for computational power you use. And vice versa, the ones who contribute to the network, their computational power, will get rewarded for bringing it into ecosystem. Yeah, so let's have a quick look at background of decentralization and how we came to this point of Web3. We came from Web 1, where we had simple static web pages. Then Web 2, we have more interactive web pages where you could do more actions. They look way better. And we have right now Web 3, which is stays on decentralization, which is based on blockchain. So you can be sure in data that it cannot be altered afterwards once it's written, and it's peer-to-peer. So we want to get the benefits of transparent, equitable digital ecosystem through using blockchain technology. Yeah, so let's have a quick look at potential, at related work, how problems are solved right now. We have those centralized clouds like Google Cloud or AWS, which are very costly, have some good security, and have very high complexity. So you always need some specialized people to deal with it. We have decentralized compute, some tokenized compute from projects like Golem or iExec. But the thing is that they stop their abstraction level at virtual machines, so you still need some good knowledge to deal with it. We have as well agent-based AI like SingularityNet, which have pretty high complexity to deal with. And Ratio1 tries to solve all of them by bringing in low-cost computational power at excellent security and at the lowest complexity possible, like making it low-code or even no-code, so anybody can use it to deploy an application or to train an AI model. Let's have a look at core concepts of Ratio1. So at the very first layer, at the bottom, we have the heterogeneous hardware. It could be anything. It could be a laptop. It could be a Raspberry Pi, or it could be a computational server. Anything you can bring into the network and contribute with it. At the second layer, there is MetaOS kernel. We have job scheduler, which decides if a job has to be rescheduled or it has to be set on a different machine because the one it was running before went down. We have plugin manager. We have some storage tools like CStore or OneFS, and we have Oracle Sync, which we have a network of oracles who decide if network is working well, if it's not working well, if there are any malicious nodes in the network. At the third layer, we have license and authenticated nodes. So basically those are the nodes who will do the computation itself. Those are the ones who have a license, which is an NFT, which lets you to authenticate into the network. And at the highest level, we have the oracles, we have the users and the smart contracts, how users interact with the network, how they are deploying some jobs, and how rewards are split between the nodes which contributed to the network. So yeah, let's have a look at historical synchronization. It's based on PBFT, on practical Byzantine for tolerance consensus. So all the oracles have to get to a consensus on some actions into the network. For example, if a node was doing well executing this AI job during the last day or longer period, and they are doing this real time. And yeah, all the data, all communication between oracles is always encrypted, even between any two nodes. Data that is sent from node A to node B is always encrypted, which keeps it safe to share. So for as decentralized storage, we have R1FS and the C-store. R1FS is IPFS based decentralized file storage, which comes with some more benefits over IPFS. That R1FS by default is encrypted, so you could access well, it's intended for storing big files. So you could upload one file on node A, and you could download it directly on node B. That's how it works, yeah. And we have the C-store is like a Redis in-memory decentralized storage. So you could use it, for example, you write some data on node A, and in less than a second it becomes available on node B. For example, node A is in United States, you write some data, and this data becomes available in less than a second in Europe. So beautiful, right? And for nodes to access the network, they should get the connection credentials. And how could you do it in a trustless environment? That's where decentralized authentication steps in. It's based on when a node starts, it does a request to the auth, and we check if this node has a license, if this license is valid, and if everything is all right, the node will get its authentication credentials and will get connected to the network. Yeah, so some practical implementations and applications where you could use this. You could use it in real estate. We'll have an example in the next slide. You could use it in healthcare to encrypt the user's health history, health records, and keeping them privately, keeping them on edge where no one could access them. And yeah, supply chains is another great example, because when you have tamper-proof GPS and logs, you could see that everything was all right while these goods were brought from point A to point B. So yeah, the real estate example is an application IHO. It's an application we have built with one of our partners, with Build21. It's like a marketplace where you could connect AI modules to your apartment, to your house, so making it more AI enabled. For example, I don't have much examples here. For example, let's have a look at the maintenance monitoring module, which is where you get a stream of data, which are basically temperatures at any point in time. You have the sensor which reads this data, and we have the maintenance monitoring module. Oh yeah, I could do it with my mouse. We have the maintenance monitoring module which detects any anomalies in temperatures. For example, temperatures went high very quickly, and once there's any alert, any change in it, you will get an alert on the backend, or you could send an alert in a mobile application. And yeah, to notify the user that, hey, look, there is a very quick temperature increase in your apartment. So the model is basically, you have the device for capturing the data. You have a thread which does the data capturing. We have the plugin who does the checks if everything is all right, and we have basically the endpoint, or the highest level where you can access the results if everything is all right or not. I won't get into details of this project right now because I'm out of time, unfortunately, but here is described how we are getting the data from the sensor itself. Why is done in a data capture thread, which is a separate thread. So you could have multiple high-level modules which use this data capture thread. So all of them are separate, and if one breaks down, it won't break down the whole system. How sensor data is turned into insights, how we decide if it's an anomaly or not. We had a small model, I think, there, who was deciding if it's an anomaly or not. How results are shared with the front end, and how easy it is to deploy everything using Ratio1 SDK, where you have just to specify the module, and you set the config, which are basically credentials for your sensor. A different plugin is about home safety, which is a computer vision plugin, which decides if, for example, which does a check if anybody wants to break into your house and stays by your door longer than 30 seconds, let's say. For example, it takes you less than 30 seconds to open the door, but if somebody is under your door longer than 30 seconds, it's a concern. It becomes a concern for you. Yeah, how it's deployed, how easy it is to deploy, and how easy it is to work with it. Unfortunately, no demo time for this time. And yeah, there's a small homework which consists into launching a DevNet Edge node. You could get more examples in ratio1.ai/blog. There are a lot of examples how you can launch Edge node, how you can launch an application, how you can write an application, or you can just launch existing applications. Yeah, but this particular homework consists into deploying a minimal fast IP backend and deploying and simple UI using Worker App Runner plugin. So more info you could find in blog, and yeah, there are some papers you could read which are really good. You could check Ratio1 GitHub. All of our code is open source, so you could check it by yourself. So yeah, thank you for attention. This was really quick overview. I'm out of time right now, so thank you very much, and keep learning. And never forget that your AI is your data. Thank you.